Hello and welcome to this e-module on Fire Systems Part 2, Detection and Alarm Systems. Let's look at the learning objectives of this e-module. By the end of the e-module, you will be able to explain what are fire detection and alarm systems, learn why fire detection and alarm systems are needed, understand the operation of fire alarm system, know the types of fire detection and alarm systems. Understand the components of fire detection and alarm system. Know the original equipment manufacturers, that is OEMs, of fire detection systems. Understand its impact on business. Learn about the service levels to be maintained. Know what are the maintenance checklists. Learn the top issues and understand its troubleshooting. Let's begin with introducing the topic. In the previous module, we learned how a fire in a facility can be very damaging and devastating. While prevention is the best means to avoid losses due to a fire, fire incidents may still occur despite the prevention measures in place. In such circumstances, the earlier the fire is detected, the better it is. An early detection coupled with an alarm will facilitate an alert to the emergency response team and send notification to building occupants about the fire and evacuation if so required. If there are any fire suppression systems connected to the fire alarm system, the same can be activated through the fire alarm. Automatic fire detection and alarm systems, when combined with other elements of an emergency response and evacuation plan, can significantly reduce property damage, personal injuries, and loss of life from fire in the workplace. In this module, that is part 2, we will learn more about detection and fire alarm systems, what they are, how they operate, the different types of alarm systems and their components. The regular and periodic testing, inspection, and maintenance of the detection and alarm systems are very important and should not be overlooked for obvious safety concerns for life and property. All systems related to fire safety must be kept updated always so that one is prepared for any emergencies at any point of time. Now, let's get started. Now let's understand what is a fire detection and alarm system. A fire detection and alarm system has multiple devices working together to detect a developing fire emergency in a timely manner and to alert the building occupants and emergency teams through visual and audio means, the alarms. The detection is carried out by automatic smoke or heat detectors or aspirating type detection systems. Video systems are also increasingly being used to detect fires. The activation of the detector must be processed by a system and alarms, audio or visual, being raised accordingly, and for this purpose the devices are connected to a fire alarm panel. If necessary, provision is also made to activate the alarms manually. The fire alarm panel is in turn connected to hooters, strobe lights or PA system to alert the occupants, that is, fire alarms. Why do we need fire detection and alarm system? Let's now learn the need of these fire detection and alarm systems. Human life, business continuity, and avoiding financial or reputational loss is every company's topmost priority. A fire in the facility has the potential to negatively impact any business, and hence the need to detect the fire in a timely manner to initiate control measures while alerting the building occupants of the fire and allowing them to evacuate in a safe manner. Let's look at some of the functions of the fire and alarm systems. Depending on the anticipated fire scenario, building and use type, number and type of occupants, and criticality of contents and mission, these systems can provide several main functions. They provide a means to identify a developing fire through either manual or automatic methods. They alert building occupants to a fire condition and the need to evacuate. Some systems may be configured to automatically initiate announcements through the public address system, that is, PA system. Another common function is the transmission of an alarm notification signal to the fire department and police department or other emergency response organization. They may also shut down electrical, air handling equipment or special process operations like card access, production machines, etc. They can also be used to initiate automatic suppression systems. It is an important part of the statutory requirement from the local government authority to have such system inspected on a yearly basis by a fire officer or an authorized agency. Now that we know the basics of fire alarm systems, let's look at its operation. In its basic form, detectors or manual call points are connected to a main fire control panel through a network of wiring in circuits or zones. A circuit comprises of an unbroken path of wires along which an electric current flow. A zone is a group of one or more detectors grouped by location. The main fire control panel drives the circuits or zones, passing current through them and monitors the current drawn. In the standby condition, the detectors will draw a very low current. When any of the detector senses a fire, it switches into an alarm condition and draws a higher current which is sensed by the control panel and appropriate alarm is triggered. A call point simulates a similar condition when it is operated manually by any occupant. Let us now see the various types of fire detection and alarm systems. Fire detection and alarm systems can be broadly classified as manual, conventional, addressable, and wireless system. Let's learn how the manual systems work. In manual type of configuration, only the manual call points are connected to the fire alarm panel and it is presumed that someone will activate the manual call point in the event of a fire. The fire alarm panel will trigger an alarm via hooters, or sounders or bells. Now let's see how conventional fire alarm systems work. In a conventional fire alarm system, several call points and detectors are wired to the fire alarm control panel in zones. A zone is a circuit and typically one would wire a circuit per floor or fire compartment. The fire alarm control panel has several zone lamps. The reason for having zones is to give a rough idea as to where a fire has occurred. This is important for the fire brigade and of course for the building management. The accuracy of knowing where a fire has started is controlled by the number of zones a control panel has and the number of circuits that have been wired within the building. The control panel is wired to a minimum of 2 sounder circuits which could contain bells, electronic sounders or other audible devices. Each circuit has an end-of-line device which is used for monitoring purposes. The detector will remain latched in the alarm state with its LEDs illuminated, even if the smoke or heat is removed until it has been reset from the panel by momentarily removing power from the line. This allows the fire to be located. Standard conventional systems can monitor the zone for short circuit, open circuit, and detector head removal. When a short circuit occurs on a zone, a high current will be drawn and the line voltage will be pulled towards 0 volts. The panel detects the low voltage or high current and a fault is signaled. In order to detect an open circuit or detector head removal, a device is connected across the end of the zone which can be monitored. This device can take various forms dependent on the control panel and is called an end-of-line device. Similarly, a fire alarm panel also constantly checks the sounder circuit by sending a reverse polarity signal through a diode. An end-of-line resistor draws a constant current. If the resistor stops drawing current, it means the sounder circuit has opened somewhere. In case of a short circuit, a higher current is drawn. To activate the sounders, the panel sends a signal in the positive direction which passes through the diode. There are some advantages and disadvantages of conventional systems. Let's see what these are. The advantages of conventional systems are: they are relatively simple for small to intermediate size buildings. Servicing does not require a large amount of specialized training. The disadvantages of conventional systems are: for large buildings, they can be expensive to install because of the extensive amounts of wire that are necessary to accurately monitor initiating devices. Conventional systems may also be inherently labor-intensive and expensive to maintain. Each detection device may require some form of operational test to verify it is in working condition. Smoke detectors must be periodically removed, cleaned, and recalibrated to prevent improper operation. With a conventional system, there is no accurate way of determining which detectors are in need of servicing. Consequently, each detector must be removed and serviced, which can be a time-consuming, labor-intensive, and costly endeavor. If a fault occurs, the trouble indication only states that the circuit has failed, but does not specifically state where the problem is occurring. Subsequently, technicians must survey the entire circuit to identify the problem. Let's look at the addressable systems now. The detection principle of an addressable system is similar to a conventional system, except that the control panel can determine exactly which detector or call point has initiated the alarm. In this system, the detection circuit is wired as a loop and up to 99 devices may be connected to each loop. The detectors are essentially conventional detectors with an address built in. The address in each detector is set by DIL, that is dual inline switches, and the control panel is programmed to display the information required when that particular detector is operated. Loop isolation modules are available for fitting onto the detection loop or loops such that the loop is sectioned to ensure that a short circuit or one fault will only cause the loss of a minimal part of the system. Another version of the addressable system known analog addressable system is deployed with advanced technology. Here, the detectors themselves evaluate the conditions around them and communicates to the control panel whether there is a fire, fault, or the detector head needs cleaning. These systems are also known as intelligent systems. Lastly, see what wireless systems are. Wireless fire alarm systems are an effective alternative to traditional wired fire alarm systems for all applications. They utilize secure license-free radio communications to interconnect the sensors and devices, that is smoke detectors, call points, etc., with the controllers. It is a simple concept which provides many unique benefits and is a full analog addressable fire detection system without the need for cables. Now, let's look at the components of a fire detection and alarm system. Let's understand how primary power supply and backup help in the alarm systems. Two power supplies are required, that is, mains and battery, and these are normally built into the fire alarm control panel. The primary power for the alarm system is usually supplied in the form of 124 volts or 240 volts AC from the power company. Standby or backup batteries must allow the system to operate without mains for 24 hours longer than the building is likely to be unoccupied and then support the sounders for an additional half hour. If the main supply is supported by an emergency generator, then 6 hour standby plus half an hour alarm load is sufficient. All modern fire alarm systems are 24 volts. Standby batteries are invariably of the sealed lead-acid variety, as use of nickel-cadmium batteries is not cost-effective. The next component is Fire Alarm Control Panel FACP. The system hub monitors inputs and system integrity, processes the inputs, controls outputs, and relays information. This main control panel may be accompanied by a remote panel or a repeater panel in larger facilities. The fire alarm control panel is the central brain which monitors and manages all the initiating devices and sends signal to indicating devices if an issue is detected. In each fire alarm control panel, the display provides information of the system status with troubleshooting codes and a touchpad to manage the system directly. From this system, one can disable alarms, signal alerts, reset the system following an issue, and reprogram when called for. When a fire condition is detected, the control panel can carry out a range of activities including sound the evacuation alarms for the facility, notify the fire service, notify the building management, close fire and smoke doors, start up smoke handling and ventilation systems, initiate operation or shutdown of other building services. Next are the fire alarm initiating devices. Fire alarm initiating devices are the activation stations and can be manual call points or pull stations, or automatic, that is smoke or heat or CO detectors. Let's now look at the list of initiating devices commonly used. Let's understand what is a manual call point. A fire alarm pull station is an active fire protection device, usually wall-mounted, that when activated initiates an alarm on a fire alarm system. In its simplest form, the user activates the alarm by pulling the handle down, which completes a circuit and locks the handle in the activated position, sending an alarm to the fire alarm control panel. After operation, some fire alarm pull stations must be restored to the ready position using a special tool or key to deactivate the alarm sequence and return the system to normal. Primitive manual stations requiring only a single action or hand motion to activate can be subject to unwanted activation by jarring or accidental contact. Early strategies to cope with this problem included requiring the operator to break a pane of glass to release an internal spring-operated mechanism. Manual pull stations that require two-hand motions, such as lift up and pull down or push in and pull down, have since replaced their break glass and single-action models. A manual call point consists of a simple switch with a resistor in series with it, usually 470 ohms or 680 ohms. The switch is held in place either by a sheet of glass or plastic or a flap. When the call point is activated, that is, glass is broken or flap is lifted, the resistor is switched across the line and a current of 50 to 80 milliamperes dependent on the control panel is drawn. Let's understand what are automatic initiating devices. There are a wide variety of automatic initiating devices which include the following: heat detectors, smoke detectors, CO detectors, flame detectors. Let's learn about them in detail. First, let's look at heat detectors. Heat detectors are used in places where smoke or dust may exist in normal conditions, like a kitchen area or a boiler room. Heat detectors are of two types. The first type operates on the rate of temperature rise. The rate of rise temperature detector may also include a fusible element for fixed temperature operation, suitable where rate of rise of heat is normally gradual. The detector will operate when it senses a rate of rise higher than the normal. This is normally a first choice when a smoke detector cannot be deployed. In some areas, the rate of temperature rise may be high, like machinery compartment, boiler rooms, etc. In such cases, fixed temperature detectors are used, which will operate when it is exposed to a predetermined temperature. Normally, fixed temperature detectors employ a fusible alloy element which must be replaced after the detector has operated. Different temperature rated elements are available to take account of varying ambient air temperatures. Now let's see what are smoke detectors. There are two basic types of smoke detectors: ionization type and photoelectric type. Ionization. A radioactive source within a chamber ionizes the air passing through the chamber. When smoke enters the chamber, the current reduces and causes an alarm to be sounded. Photoelectric. A light source and a photocell are positioned inside the chamber such that the light does not fall on the photocell. The passage of smoke into the chamber causes the light from the source to be scattered and fall on the photocell, the cell output being used to initiate an alarm. Apart from the ones we have seen earlier, some other specialized smoke detection systems are also available. Let's see what these are. Aspirating smoke detectors. An aspirating smoke detector, that is ASD, is an air sampling device that proactively sucks air from the compartment through a network of pipes and processes that smoke through a smoke sending device, which is generally similar to the photoelectric smoke detectors seen earlier. Since the aspirating smoke detectors are typically more sensitive to a wide range of smoke particulate size, they are often used as a very early form of smoke detection. A commonly used equipment is VESDA, that is VESDA, that is Very Early Smoke Detection Apparatus. Video smoke detection. As the name indicates, video smoke detection uses images from a video camera and processes the same with the help of software to detect smoke or flame in the area covered. Next are the carbon monoxide detectors. One of the byproducts of most forms of combustion is the gas carbon monoxide, that is CO. This colorless, odorless, tasteless and highly toxic gas is produced by incomplete combustion of carbon-containing compounds. Carbon monoxide fire detectors are generally suitable for a broad range of applications where the use of traditional fixed-point heat or smoke detectors may be impractical due to the presence of deceptive phenomena. Carbon monoxide fire detectors have a relatively short lifespan, 5 to 10 years, and should be maintained strictly in accordance with the manufacturer's recommendation for optimal performance. Lastly, let's look at flame detectors. Flame detectors respond to the production of one or a combination of ultraviolet or infrared spectrums of electromagnetic radiation. These detectors are often used in situations where there is a potential for the rapid development of fire, such as flammable liquids. One of the methods to improve the performance of flame detectors and reduce the effect of deceptive phenomena and false alarms has been to combine both ultraviolet and infrared technologies into the one system, or 2 or 3 separate wavelengths in the infrared spectrum. Multi-sensors are the next type of fire detection devices. Let's look at these in detail. The last 2 decades has seen dramatic improvements in the ability of manufacturers to incorporate 2 or more of the technologies. This combination of technologies has improved the performance of an existing method of fire detection and in some cases to reduce or eliminate the false alarms. Upon receiving an alarm notification, the fire alarm control panel must now tell someone that an emergency is underway. This is the primary function of the alarm output aspect of a system. Occupant signaling components include various audible and visual alerting components and are the primary alarm output devices. Bells are the most common and familiar alarm sounding device and are appropriate for most building applications. Horns are another option and are especially well suited to areas where a loud signal is needed, such as library stacks and architecturally sensitive buildings where devices need partial concealment. Shines may be used where a soft alarm tone is preferred, such as healthcare facilities and theaters. Speakers are the fourth alarm sounding option, which sound a reproducible signal, such as a recorded voice message. They are often ideally suited for large multi-story or other similar buildings where phased evacuation is preferred. Speakers also offer the added flexibility of emergency public address announcements. With respect to visual alert, there are a number of strobe and flashing light devices. Visual alerting is required in spaces where ambient noise levels are high enough to preclude hearing sounding equipment and where hearing impaired occupants may be found. Voice evacuation systems. Now let's see what are building safety interfaces. The fire alarm system can be integrated with other building systems to enhance safety of the evacuating occupants as well as prevent the fire from spreading into the other areas. Other output functions may include the following: shutting down electrical equipment such as computers, shutting off air handling fans and closing of dampers to prevent smoke migration, shutting down operations such as chemical movement through piping in the alarmed area, activation of fans to extract smoke, which is a common function in large atria spaces, activation of staircase pressurization fans. These systems can also activate discharge of gaseous fire extinguishing systems or pre-action sprinkler systems. Remote alarms can be set up through the output devices, including automated messages to concerned staff or fire station. Release of access control system on doors or exit doors to facilitate free movement of occupants. Now let's look at the top manufacturers. They are EST, Edwards System Technology, UTC, Siemens, Honeywell, Johnson Control. Let's now look at the impact on the business. The fire alarm and detection systems detect and notify the occupants and the emergency response teams of a fire which has started in the monitored area. A non-functional fire alarm and detection system may either fail to detect the fire or fail to process the signals received from the detectors and hence failing to provide the required alerts. In such a case, both human lives and infrastructure is at a major risk, since delay in controlling a fire usually makes it more difficult to be controlled at later stages and also spreads the fire. In addition to the direct impact of delayed reaction, there will be collateral risk created since a non-operational or a sub-performing equipment will also not send the required signals to other facility equipment to act in accordance with the programmed fire safety actions. It means that there will be no announcement on the PA system alerting the occupants for the need of evacuation. The elevators will continue to function, causing secondary risks of people stuck in the elevator. The access control doors will not get activated, making the movement of evacuating personnel slow and difficult. The AHUs will continue to run and dampers remain open, thus allowing the fire and smoke to spread into other areas of the facility. The staircase pressurization will not come on with the result of filling of the staircase with toxic smoke and making evacuation difficult. Let's look at the service levels now. All equipment, including the main panel, repeater panels and detectors, should be operational at all times. Backup batteries, where used, should be kept in healthy condition and replaced if required. All PPM activities must be completed as per schedule. Response and resolution times of defects to be as per the agreed turnaround time. Disposal of ionization type detectors is to be done as per laid down procedures. Any isolation of parts or components of the system must be done only on approval and system restored after completion of activities. Detectors are to be cleaned after every false operation. System health and operation to be checked on a weekly basis. Let's look at the maintenance checklist. Test the master fire alarm. Check for the condition of flashing lights and loudspeakers. Activate one device on each initiating device circuit. Test lamps and LEDs on fire panels. Check the condition of batteries is fully charged. Check speakers, manual stations and detectors for damage or obstruction. All smoke detectors within premises should be cleaned out of dust and tested by simulated signal. Check all smoke detectors for damage or obstructions. Check all smoke detectors operate and give correct zonal alarms and indication on fire annunciation panel. The inspection and servicing should be undertaken by organizations with the appropriate competence. This can be assured by the use of organizations that are third-party certified specifically to carry out inspection and servicing of fire detection and fire alarm systems. The period between visits to undertake inspection and service should be based upon a risk assessment, but the maximum period between visits should not exceed 6 months. The logbook should be inspected. A visual inspection should be made to check whether structural or occupancy changes have been made that require changes to the fire detection and fire alarm system. False alarm records should be checked and relevant action taken if necessary. Batteries should be checked and tested. Fire alarm devices should be tested. Facilities for automatic transmission of alarm signals to an alarm receiving center, that is ARC, should be checked after advising the ARC of the proposed actions. All fault indicators and circuits should be tested and checked. Printers should be tested. Other checks and tests recommended by the manufacturer should be carried out. Outstanding defects should be reported and the logbook completed and servicing certificate issued. The recommended period between successive inspection and servicing visits should not exceed 6 months. Vented batteries should be examined by a person with relevant competence and should be topped up if necessary. The inspection and testing of a system over a 12-month period should include following. The switch mechanism of every manual call point should be tested. Every automatic fire detector should be examined and functionally tested. This includes, but is not limited to, smoke detectors, resettable heat detectors, optical beam smoke detectors, aspirating fire detection systems, carbon monoxide fire detectors, and flame detectors. All fire alarm devices, both visual and audible, should be tested. Certain filament lamps should be replaced. Radio fire detection and fire alarm system signal strengths should be checked. Visual inspection of readily accessible cable fixings should be undertaken. The cause and effect program should be checked. The standby power supply capacity should be checked. Other annual checks and tests recommended by the system component manufacturers should be undertaken. Outstanding defects should be reported and the servicing certificate issued. As this is labor-intensive servicing, it is recommended that the work can be spread over 2 or more service visits during each 12-month period. Let's now look at the top 5 issues caused to the fire detection and alarm systems and the ways to troubleshoot these issues. Low battery on main control panel. Cause: check for normal control panel battery life. It is about 2 to 5 years. Troubleshoot idea: replace the battery in the control panel. No power supply. Cause: control panel outage, power outage to the house, loss of power to plug transformer for the system is dead. Troubleshoot idea: check the plug that the system transformer, a little 3x3 cube, is plugged into. It could be dead due to lack of power to the house, a tripped circuit breaker, or a popped GFI plug, usually located in the basement. Reset power. All should go back to normal, unless the transformer for the system went bad. If that happened, you'll need a service call. False fire alarms. Cause: dust in the area or a dirty detector can initiate a false alarm. Other reasons can be steam from bathrooms, showers, etc. Fumes from cooking process. Tobacco smoke. High humidity. Accidental, that is manual call point. Aerosol spray. Water egress. Troubleshoot idea: detectors need to be cleaned on a regular basis. Every false alarm must be checked and an alarm shall never be presumed to be false. New intelligent sensors calibrate themselves to cater for change in environmental conditions. Low battery on wireless devices. Cause: check for normal battery life of wireless devices. Normal battery life on a wireless device is 3 to 5 years. Troubleshoot idea: replace the battery in the device that has a low battery or schedule a service call to have trained technician replace the battery. We highly recommend replacing all wireless device batteries when one is showing up as low. General wiring problems. Cause. Some wiring from the control panel to the devices in the house is supervised for integrity. If a wire gets cut, chewed through by animal or just breaks, this could cause a trouble condition on the system. Troubleshoot idea. There is usually nothing you can do to fix this trouble condition. A service call will be needed so that a trained technician can assess and fix the problem. In this e-module, you learned the following. What is fire detection and alarm systems? The need of fire detection and alarm systems. Operation types and components of fire system. Original equipment manufacturers, OEMs. Impact on business. Service levels to be maintained. Maintenance checklist. Top 5 issues or troubleshooting ideas.